Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the today's discussion will be about the solid which has been cut by a section plane which is inclined to HP and perpendicular to the vertical plane. So this cutting plane is called auxiliary inclined plane. So here we have an auxiliary inclined cutting plane which happens to be inclined to HP at an angle theta, and this cutting plane happens to be perpendicular to the vertical plane. Now as the solid, we can see over here, as the solid is being cut by an AIP, so the upper portion of the solid will be discarded or will be thrown out, and we are left with this remaining portion of the solid. So we can see that in the front view we are able to obtain the edge view of this cut section, and while we look at this section solid from the top, then in the top view we are able to see the apparent shape of this cut section over here. So we are not able to see the true shape of this cut section in the top view over here. Why? Because this cutting plane happens to be inclined to the horizontal plane at an angle theta over there. So that is why, since the surface of the cut section happens to be inclined with respect to HP, as we can see over here, so its projection on the horizontal plane will reveal only its apparent shape. So we will be able to obtain the true shape of this section when we are able to draw an auxiliary inclined plane parallel to this cut section or the cutting plane, and the projections on this auxiliary inclined plane that we are going to draw parallel to this cutting plane, these projections, which will be called auxiliary plane projections. So these auxiliary plane projections will be able to provide us the true shape of this cut section. So let us look into the problem that we are going to discuss today. So here we have a cylinder available with us. So this is a right circular cylinder. So this has been cut by an AIP which is going to cut the cylinder passing through the axis. So this is going to cut the cylinder passing through its axis, and this AIP, that is auxiliary inclined cutting plane, will be inclined with respect to HP at an angle of 45 degree, and it is perpendicular to the vertical plane. Now this was our cylinder, you see, and as this cylinder is being cut by this cutting plane which is passing through all the vertical generators of this particular cylinder. So here we have divided the circle, that is the top face or the bottom of this cylinder, into 12 equal parts. So we have got 12 generators over here. So since this AIP is passing through all the generators of this cylinder, so the numbers or number of points of intersection that are going to be obtained will be equal to the number of the generators of this particular cylinder. So since there are 12 generators, so the points of intersection will also be 12 over here. And we need to understand one very simple thing, that whenever a cylinder is cut perpendicular to the axis, then the true shape obtained will be a circle. That is, if I cut it parallel to the horizontal plane. Had I cut this cylinder parallel to the horizontal plane, so in the top view I would have obtained the true shape of this particular cut section over there, which would have been again a circle over here. But if this cylinder is cut by a cutting plane which is inclined to the horizontal plane and it passes through all the generators, so irrespective, you see, of the degree of inclination, even if it is cutting in this direction, it is cutting in this direction, or even if it is cutting in this direction, but the only condition is that this AIP should be passing through all the generators, or it should be cutting all the generator. So the top view which will be obtained over here will be the apparent shape, and this will be once again a circle over here. That is, even if it is cutting in this direction, or even if it is cutting like this, or even if it is cutting like this or like this, the top view will be a circle. Why? Because all the POIs, they are going to lie on the vertical generators of the cylinder. So whenever we are going to look from the top, so all these cutting points, they are going to coincide with the vertical edges, that is 1 dash and 1 dash, 12 dash and 12 dash, similarly 10 dash and 10 dash. So all the vertical generators are there, so all the POIs will be located on the vertical generator. So the top view will not be able to comprehend that in which direction I am going to cut this particular cylinder. So this will be the apparent shape of the cut section, and whenever my AIP passes through all the generators, irrespective of the angle of cutting, I am going to get the top view as the circle over there, right? So the section view will be the apparent shape. So this view, we are going to say that this is the shortened view of this cut surface, and it does not do justice to the angle of inclination. So even if the surface of the cut section is bigger or smaller, this will always be a circle over there till our AIP passes through all the generator. So this is inadequate to describe the shape of this particular cut surface. So if we have to obtain the true shape of this cut surface, then we need to draw another auxiliary inclined plane parallel to this cut surface or the cutting plane, and the projections obtained on this AIP, that is the auxiliary plane projections, they are going to describe the actual shape of the cut section over here. So now whatever is, even if the angle of inclination is changing, this shape of the ellipse will be changing over there. So when the cylinder is cut by cutting plane inclined to its base or the horizontal plane, and it cuts all the generators, then the true shape will be an ellipse. So depending upon the orientation of this particular cutting plane, the size of the ellipse will be changing over there, right? And if the cylinder is cut by a cutting plane parallel to its axis, had I cut it parallel to its axis, then the resultant shape would have been rectangle. So now let us work out this problem. Let us read out first of all the statement of the problem over there. So here a cylinder of diameter 30 millimeter, that is this diameter is 30 millimeter, and axis height 55 millimeter, that is the distance between O dash and this O1 dash happens to be 55 millimeter. It is resting on the horizontal plane on the base over here, that is on its base, that is which is a circle, and it is having its axis located vertically over there, that is the axis is parallel to the vertical plane, and it is cut by a section plane which is perpendicular to VP and inclined at an angle of 45 degree to HP. So this is an AIP perpendicular to VP and inclined to HP at an angle of 45 degree, and it is intersecting the axis 30 millimeter above the base. So from here you move 30 millimeter upward, so this distance will be 25 millimeter and this distance will be 30 millimeter, right? So let us see how can we go about working out the projections of this particular solid. Now first of all, since this solid is resting onto the ground on its base, so the top view or the true shape of the base or the top face will be drawn as a circle over there. So this is a circle having diameter 30 millimeter. Now having drawn this circle, that is the top face or the bottom or the base of this particular cylinder, I need to divide this into 12 or 8 equal parts. So here I have divided this circle into 12 equal parts. So this is the plan of my cylinder. So the plan of the cylinder has been obtained on the horizontal plane in the top view. So that is why it has been drawn below the XY reference line. So let us do the numbering. So 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, all these points, they are lying on the top face of the cylinder. Whereas 1, 2, 3, 4, 5, 6, so these are the points which are lying just below these points which were there on the top face. So these are the points which are lying on the base. Now the reason, you see, why we we are having the similar numbering, the reason is quite simple, because 1 and 1, 1, we always remember that these are the vertical generator, because the number of points, they are on the higher side. So getting 24 points over here would be difficult otherwise. So having drawn the top view, now we are going to work out the front view of this particular cylinder. So we are going to draw the projectors through all these points of the base, and we'll getting the points of projection onto the vertical plane, onto the XY reference line. But before that, let us work out the axis height. So once we work out the axis height, the front view of the cylinder can be worked out, and you can see this is my axis, which has been worked out to be 55 millimeter. Now we have drawn the projectors through all these points, and then you can see I am going to do the marking of the top face points and the bottom base points over there. You see, if I draw projector through 1, so the base projection will be 1 dash. If I draw projection through 2 and 12, base projections will be 2 dash and 12 dash. Similarly, projectors through 3 and 11, they give me 3 dash and 11 dash on the XY line. Projectors through 4 and 10, I am getting 4 dash and 10 dash onto the base or the XY reference line. If I draw projectors through 5 and 9, so the base projectors will be 5 dash and 9 dash. Similarly, through 6 and 8, I am getting 6 dash and 8 dash projectors on the XY reference line, that is onto the base. And finally, if I draw projector through 7, then 7 dash is the projection which is obtained on the base. So similar projection they are obtained onto the top face of this particular cylinder. Now these are all, you see, the vertical generators, 1 and 1 1, and 2 and 2 1, 12 and 12 1. So in the front view, these points will be labeled as 1 dash 1 1 dash, 2 dash 2 1 dash, 12 dash 12 1 dash. Similarly, 4 dash 4 1 dash, 10 dash and 10 1 dash. Over here, 6 dash and 6 1 dash, 7 dash and 7 1 dash. So these are all 12 vertical generators. Now my cutting plane has to pass through a point on the axis which is lying 30 millimeter above the base. So 30 millimeter above the base, the axis point will be cut by a cutting plane which happens to be inclined to horizontal plane at an angle of 45. So this is the angle of AIP. This plane happens to be perpendicular to the vertical plane and inclined to HP at an angle of 45. So we have drawn this plane. Now you can see this portion of the solid has been cut. Okay, so this portion of the solid has been cut and will be discarded. And all these vertical, you see, projectors, 1 to 1 dash, 1 1 dash to 1 dash, similarly 2 1 dash to 2 dash, and similarly all these 12 projectors, they will be cut. You see, all the 12 vertical generators, artificial generators, they have been cut by this cutting plane. So the 12 points of intersection, they will be located. Now I am going to name these points once again for the simplicity. Intersection point is P, and 1 2 3 4 will be the points which are going to lie on the corresponding vertical generator. So here you see I have marked all the 12 points over here. So P1 dash has been marked as point of intersection of the vertical generator, 1 1 dash and 1 dash. P2 dash, it is the point of intersection of the vertical generator, 2 1 dash and 2 dash. And P12 dash, it is the point of intersection of the cutting plane with the generator, which is 12 1 dash and 12 dash. So similarly all these P points, so we have just followed this chronology that depending upon the number of this point, so we have added P in front of it. On whichever vertical generator any particular point of intersection is lying, so its numbering is P and then same number of the point followed by the dash over there. So all these 12 points, they have been located. Now since all these 12 points, they have been located in the horizontal plane, please check, I need to work out the top view of all these points. So for that I am going to look from the top. So as I am going to look from the top at this cylinder, so all these points of intersection, you see, since they are lying on the vertical projectors over there, so they will be falling upon the same vertical projector where they were lying on the elevation view. So here you were getting the exact location of the point, but when you look at from this particular generator or any other generator from the top, so you will find that the two, you see, ends of the generator, they were getting coincided over here, and the similarly the P point, that is the cutting point or the point of intersection of that generator, it will also be coinciding with the respective vertical generator. That is the point P1 dash, which was lying on 1 1 dash and 1 1 and 1 dash, it will be coinciding with 1 1 and 1 point. So this will be the cutting point or the intersection point of P1. P2 point will lie here, P3 point will lie here, P4 point will lie here, and P5 point will lie here, P6, P7, P8, P9, P10, P11, P12. So all these points, they will be lying on the corresponding vertical generator which we have already drawn. So in the top view, since all the vertical generators are there, so whether you are going to have 2 points on this generator or you are going to have 3 points on this generator, so the vertical projection will be lying at the same point. So therefore 11 1 11 and P11, they will all coincide. 10 1 10 and P10, that will also coincide. 9 1 9 and P9 will also coincide. 8 1 8 and projection of the intersection point P8 will coincide. So similarly, all these P points are the points of intersection of the cutting plane with the respective vertical generator. So all these points of intersections in the top view, they will be coinciding with the vertical generator over there, right? Now you see, that is why I told you that even if the angle of inclination was not 45 degree, even if it is 30 degree, or even if this is 60 degree, still, so long as this cutting plane is not passing through the sides of the base over there, it is cutting all the generators, even if the angles they are changing or even the orientations are changing, top view will be a perfect circle over there, because all the vertical projectors, they will be coinciding with the generators, that is 1 and 1 1. So 1 was here, 1 dash, 1 1 dash was here. So it was a vertical generator. So all these 3 points, they are going to coincide at the same point. So this is our section top view. So it does not provide us the clear picture of the shape of this cut section over here. So that's why we call it, this is a section top view, and it represents the apparent shape of the cut section in the top view. Okay, now we want to draw the true shape of this cut section. Whenever we want to draw the true shape of the cut section, what we usually do, we are going to draw another auxiliary plane which is going to be parallel to this cutting plane. You see, we are going to draw another cutting plane, auxiliary inclined plane, which will be parallel to this cutting plane. And since this cut surface will now be parallel to this auxiliary inclined plane, so the projections through all these 12 points, you see, these are 12 points, and how I am going to project them over here, you see, 7 projector generators I am going to draw over here. On the outermost side, you see, I am having 2 points, that is P1 dash and P7 dash. So outermost projectors will have only 1 point, whereas the interior 5 projectors which I am going to draw from P2, P12, and then P3, P11, P4, P10, P5, P9, and P6, P8. So these projectors, they will be carrying 2 points over there. You see, outer projectors, they will be carrying 1 point of intersection, whereas inner 5 projectors over there. So this projector will be carrying projections corresponding to, you can see, 6 and 8. So 6 and 8 points will be lying over here. Point 7 will be lying on this. Similarly, 5 and 9, this projector is corresponding to P5 dash and P9 dash. So points 5 and 9 will be appearing over here. Similarly, 4 and 10 will be appearing over here. Similarly, 3 and 11 will be appearing on this projector line. And 2 and 12 will be appearing here, and first point will be appearing here. So let us work out the projections of all these points of intersection in this auxiliary plan. And now you see, since this view is called auxiliary plan, so we are required to draw the distances of all these points of intersections P1, P2, P3, P4, P5, P6, 7, 8, 9, 10, 11, 12 from the reference line. So we are going to measure the distance of these points of intersections from the XY reference line, and on the corresponding locus line we will be transferring this distance in front of the auxiliary plane, that is AIP. So let us start doing it. So the first point is point number 1. So please see, point number 1 is located over here, P1. So P1 location in the top view is this point, and from this point I will be measuring this particular distance from the XY reference plane. So I'll be using divider over here. Using divider I am going to measure this distance, and the same distance will be transferred over here onto the first locus line. Why onto the first projector I am drawing? Because this is first projector has been drawn corresponding to the point P1 dash. So the distance of P1 will be projected over here. Just see, this is P1. Now let us say second point P7, because outermost points I have identified first. So P7, it is also at the same distance as that of P1. So whatever distance was P1 located, at the same distance my point P7 is also located. So that is why I have measured this point distance over here onto the locus line which was originating from P7 dash. So the name of this point is P7. Now next, you see I am going to measure this point 12 and 8 over here. So half semicircle and parallel points I will be picking up, 8 and 12, 11 and 9, and then 10. So point 12, you see point 12 distance from the XY reference line is this one. So this is the distance of the P12 from the XY reference line. I have measured that point and then marked it over here. Similarly, P8 is also at the same distance. You see 12 and 8, they are having the same distance from the XY line. So that's why I am measuring 12 and then 8 over here. So this is the location of P8. Why I have located P8 here? Because it is originating from locus line of P6 and P8 over here. Next, you see I am looking at this point which is 11, P11. So the distance of P11 from XY reference line is this, and this distance is same as distance of P9 from the XY reference line. So P8, 11 has been made and P9 has been shifted over here. So 11 and 9 points, you can see P11, it is at this distance. Similarly, P9 is also at the same distance. And finally, P10. So this is the distance of P10 from the XY reference plane. So P10 is also shifted. Now next we move on to these points. So in order to start with this, you see I have marked both of these points simultaneously. This point is point number 2. This point is point number 6 over here. Just see, this is the distance of 2 from XY. So I measured this distance of P2, and same is the distance over here corresponding to P6. So P6 and P2, they are having the same distance from the XY reference line. So just see, P2 and P6, they have been shifted simultaneously. Next, P3 and P5, just check. P3 and P5, they are at the same distance from the XY reference line. So I measured the distance of P3, it will be equal to the distance of the point P5. So that is why you see 2 points P3 and P5, they have been located and they have been labeled over here in the auxiliary plan. And finally, 1 point is left, point number 4. It is farthest away from the XY reference line. So I am going to measure the location of this P4 which is situated here, and then measure this distance of P4 from the XY reference line, and then P4 will be drawn over here. And having drawn all these 12 points, now you can see this is a perfect ellipse which I have been able to obtain. So this is the true shape of the cut section, so which justifies the statement that whenever a cylinder is cut with an AIP which is inclined with respect to HP and perpendicular to VP, cutting all the generators, the true shape of the cut section will be an ellipse over here. Now this is the cut section. So the shading has to be done at an angle of 45 degree to the X1 Y1 reference plane. So now this shape, that is the auxiliary plan which we have obtained on the AIP for all the points of intersection. Now since this was obtained on AIP which was parallel to the cutting plane, so the projections which are obtained on AIP in the form of auxiliary plan, this will be giving us the true shape of this cut section. So this is all about discussion regarding projections of cylinder today. So thank you very much. Thanks a lot.